Now, continuing with our person, student, teacher example, we have previously seen how powerful polymorphism is in object-oriented programming and how it allows the objects to change their behaviors throughout the program. We saw how a person can act as a student or also as a teacher. This was done by the use of inheritance and the virtual functions. To take it one step further, we can now introduce pure virtual functions that can impose a certain behavior across the child classes while ensuring that each child class has its own unique implementation of that behavior or function. Now, what's the difference between a virtual and a pure virtual function? Well, a virtual function creates a default implementation of a function that the child classes can override and build upon it. We saw this in our print function for the person, where the base class has a default print of the person attributes, such as the name, the SSN, and the occupation, whereas the student and teacher print functions called the base class print function while adding the cout statement for their own attributes. However, a pure virtual function is used to make a class abstract. An abstract class does not allow you to directly create an instance of that class. And also, a class is said to be abstract if it has at least one pure virtual function. So let's create a pure virtual function in our parent class. So virtual, and let's have it return a string, and let's name the function get occupation type. And we'll say constant, and to make it a pure virtual function, it must be equal to 0 and have no implementation. So a pure virtual function is defined by adding the equal 0 at the end, and it does not have any implementation in the parent class. This is because the implementation will be done in the child classes only. So in the child class, let's have the virtual string function get occupation type constant, and we must override. So the occupation of a student, we will just return student, make it a very simple function. And similarly for the teacher, it will have the same implementation, however you just return teacher instead of student. So now we see an error in the main, and it says object of abstract class type person is not allowed. So as we previously mentioned, we cannot directly create an instance of an abstract class. So we can't have new person with the constructor. So let's change the people array to make it only 2 elements. And also we have to change the size of the for loops. So now we have a people array for a student and a teacher at index 0 and index 1. Okay. So now let's verify that the pure virtual function works properly. So let's have another for loop of size 2, because the new array is of 2 elements. And then let's print out people at index I dot get name. So we will print the person's name and their occupation. So name is A, and then we print the occupation type. So people at index I and get the occupation type. And let's end the 9. And let's have a break between the 2 statements. And let's run the code. So the print function is the same as previously, we just don't have the person print. And Bob is a student and Charlie is a teacher. That's from the pure virtual function, saying that our student Bob is a student and Charlie is a teacher, and the destructors are the same. They have the same order because the inheritance is still the same. So since we established that you cannot directly create an object from an abstract class, the person class, someone might ask, well, what's the importance of having a constructor and parameterized constructor for the abstract class person? Well, to answer this question, the constructors are still useful for initializing the shared attributes that will be inherited by the derived classes. So when you create an instance of a student or teacher, the base class constructor, the person constructor, is called first. Now this makes sure that the common attributes between student and teacher, which are the name, the SSN, and the occupation, are properly initialized. So the person class provides the student and teacher classes with a blueprint, the default blueprint that the student and teacher class can build upon by the use of the virtual and pure virtual functions. This creates the interface between the derived and the base class. So to summarize, polymorphism provides flexibility in designing our code by allowing different derived classes to share a common interface while implementing specific behaviors. These behaviors are implemented through the virtual functions. And pure virtual functions create abstract classes while ensuring that the derived classes must implement that function. So the three pillars of polymorphism are creating a base class pointer, assigning a derived to a base class, and the virtual keyword.